And good morning, or good afternoon, or good evening, folks. This is Mr. Callan coming at you with some help with Pythagorean theorem. We reviewed this a bit ago. We're going to bring another review back in preparation for next week. And so we'll begin. Now, there has been some misunderstanding with homework assignments. Yes, I do put the answers on there sometimes, not unlike, well, the odds in the back of the textbook. And I always encouraged you. Do some problems, check to see if you're doing it right. If, however, this seems to be too much of a distraction for you, what you could do is just take a pen and color over each of those answers, and then after you complete the problem, when you're ready, you can go back and you can erase it to see if it's right. So that's what I will do. Meanwhile, let me go ahead and zoom in and begin number one. Directions here are determine whether each triangle with sides of given lengths is or is not a right triangle. And yes, they're asking us to justify our answer. Anybody can guess correctly by writing yes or no and get it right maybe half the time. So we'll go ahead right now and begin with number one, remembering, please, that the Pythagorean theorem is the formula the square of the two legs added together must equal the square of the hypotenuse. Now remember, please, if you were to draw a right triangle, the hypotenuse is the longest edge. It is the edge opposite of the right angle. I like to think of it as little, medium, and the hypotenuse is the big guy. Now notice for the front page, we do not have actual pictures, so we have to pay attention to the size of the numbers. If I were to write down a squared plus b squared equals c squared, if in fact these numbers make a right triangle, 197 is the largest, that would have to be the hypotenuse. Meanwhile, I would then write in 28 and 195 and square them. But one thing I'm going to write in is a little question mark. I don't really know if these are in fact equal or not. That is what we would like to prove. So we go ahead to our decimals calculator. I trust you guys can do that by now. Now I'm going to square 28 squared plus 195 squared, since those are together. They end up equaling 38,809. Then I come to the right side and I say, okay, what is 197 squared? And this ends up equaling 38,809. Well, how about that? So, because this is in fact a true statement, I'm going to come down for my answer and I'm going to write, yes, these make a right triangle. Something along those lines. Now I go on to number two, where we're going to do the same sort of thing. Oh, and by the way, yes, you can erase your answer just to make sure that you do have the correct answer. Let's go ahead to number two, where we have 30 is the smallest side, 122 is the medium side, 125 is the largest side, and I'm going to write a little question mark up here. Does this work or does it not? Well, off to Desmos, when I calculate 30 to the second power plus 122 to the second power, it equals 15,784. Meanwhile, when I square 125 times another 125, I get 15,000. Hey, good. Oh, no. This ends up being 625. So if I were to write that, I would say, no, wait a second. That is not a true statement. So then I go off to my text box and I write, no, these sides, this triangle is not a right triangle. And going to my eraser, I erase that just to check myself. At this point, you may continue on with the video, or what I would do is I'd press pause and go to my own paper and begin writing. So you should have by now gone ahead and completed 3, 4, 5, and 6. Meanwhile, what I'm going to do is I'm going to come to the back side. I'm going to do numbers 7 and 9. But before I do that, just as a reminder, I'm going to go ahead and draw out all the answers so that you don't have to see that. So let's do number 7 first. and review the directions. Write an equation you could use to find the length of the missing side of each right triangle. It says it's already a right triangle, so no need to prove that. What we're going to now do is find the missing length and, if necessary, round to the nearest tenth. So let's go on to number 7, please, where since this is already a right triangle, we know that the formula does in fact work. And if I look carefully, I'll see that the longest... time out, Mr. Callan. One habit I'm working on is to make an estimate, to guess first before actually finding the final answer. Well, if I see that one leg appears to be 27, another leg is 36, we're missing the hypotenuse. That appears to be the longest edge. I'm going to go ahead and say 40, maybe bigger than 40. Why not? Let's just say 41. Let's find out. Now, as I just mentioned, the missing piece is the hypotenuse, so we don't know what C is. However, we know the smallest and the medium-sized leg. From here, our goal is to solve for C. Let's find out what C is. But first, why not simplify? We know what 27 squared is plus 36 squared is. I can go to my Desmos calculator. I can find that if I were to square those numbers and add them up, they would equal to 2025. Meanwhile, I don't know what C times C is. I don't really want to know what C squared is. I want to know what C is. So how do we get rid of that second power? Well, the inverse of add is subtract. The inverse of multiply is divide. The inverse of a power is a root. And a long time ago, we realized that there should be two possible answers here. After all, a positive times a positive is a positive, and a negative times another negative is also a positive. However, you cannot have a negative length here. So we're really only going to have one answer. Go to my Desmos calculator, type in the square root of 2025, and we get 45 feet. Meanwhile, just to point out that the square root of a square power cancels out, leaving me with C equals. That is precisely what I wanted. So I can go now, if you guys did the same thing, erase that and check that answer. It ends up being 45 feet, which is awfully stinking close to my original estimate of 41, which kind of verifies that that makes sense. Let's go ahead and do one more problem with problem number 9. Once again, now I will write the Pythagorean theorem because we see in the drawing it is a right triangle. We are missing one of the sides. So if I bring down my equal sign here and I identify the hypotenuse first, no, freeze, Mr. Callan, time out. Let's make that estimate. So I look at one side is 10, the longest side is 15. This is going to be close, but smaller than 15. Looks to be kind of in between. So I might say 12. Yeah, we'll find out. So let's go ahead and write in a squared, 10 squared. 15 is the hypotenuse. So the hypotenuse is known. It is a leg that is missing. Now, speaking of the next steps, our goal is to solve for A, right? We want to know what A is. But why not simplify? I don't know what A times A is, but I know that 10 times 10 is 100. I know that 15 times 15 is 225. So now our goal is to get rid of this second power, to get rid of this plus 100. We want it to say A equals. But how do we do that? To get rid of a second power, we're going to take a second root. But before we do that, let's eliminate the 100. That has nothing to do with that leg. When we do that, 100 and a negative 100 makes 0. No need to write the 0. And we are one step closer to getting A isolated and by itself. Meanwhile, 225 minus 100 would be 125. Now let's go ahead and get rid of that second power. We know that the inverse of a second power is a second root, as long as we are fair to both sides. As we said earlier, there could be two possible answers to the equation, but in this case, there's only a positive possibility because you cannot have a negative leg. Second power, second roots cancel out. Go to my Desmos calculator here for the square root of 125. And we see the answer on the right side, 11.1803398. Okay, well, chances are if it goes that long, it's a crazy, ugly, irrational number, does not terminate, does not repeat. So let's round it to the nearest tenth. Is that closer to 1/10 or 2/10? Well, that's very close to 2/10. So we'll write, instead of exactly equals, we'll write approximately equals 11 2/10 centimeters. If I take a look at my guess of 12 centimeters, pretty stinking close, go ahead and erase the answer and verify that I have it correct. All right, folks, now you know me and you know the best ways to learn. Take a look at number 7 and number 9. How are those problems similar? Start off with the obvious. They're right triangles, a squared plus b squared equals c squared. How are they different? I want you to think about those, create a little step-by-step set of instructions for yourself, and continue on with the assignment. When finished, don't forget in the top right-hand corner to press submit or turn in. I think the words are turn in. And take your time, do well, folks.